Let's evaluate another definite integral using the technique called U substitution. So here's a definite integral from 0 to 1, and the function is x times e to the opposite of x squared. So once again, we're going to try to use this idea of writing your U substitution using differentials. So let's get started. Why don't we try let U equal the opposite of x squared. Now we're going to write our differentials. From that equation, we're going to write an equivalent equation using differentials. So the left-hand side of the equation is now du, and we want this to equal, what's the derivative of the opposite of x squared? Negative 2x. Okay, and then we need to multiply this to another differential called dx. So this almost fits. Notice we don't have a negative 2, but we do have an x times dx in the original integrand. Okay, we do have an x times dx here, so we want to keep that. What we want to do now is rewrite this as negative 1/2 du is now equal to x times dx. So we could divide by negative 2. Just make sure you don't divide by a variable. Okay, now we also need to make sure our x values get turned into u values. So here's x1 is equal to 0, x2 is equal to 1, so we need u1. Let's find u1. So u1, evaluated at 0, is simply going to be the opposite of 0 squared. And of course, that is equal to 0. So let's also find u2 evaluated at 1. But a u function evaluated at 1, what is that going to equal to? That is going to equal to the opposite of 1 squared. So that's negative 1. So notice the integral in black is now going to be rewritten and substituted with this integral. So 0 to negative 1, and then what do we have here? We have x dx is negative 1/2 du, and so we have what? E to the u du. Ta-da! It's quite beautiful. Let's move the negative 1/2 to the front, and we have a definite integral from 0 to negative 1 of e to the u du. Not a problem. Negative 1/2. That's e to the u. Evaluate from 0 to negative 1. And what do we get? Negative 1/2 e to the negative 1, which is what? 1 over e minus 1. Okay. So this is factored form already. I guess some of you might like common denominator, so some of you might write it like this. And so there is a common denominator in reduced factored form. That's definitely acceptable.